Look up at the night sky. For thousands of years, humans have wondered how the universe began. But there is another question just as profound. How will it end? The universe is not static. It is expanding, evolving, and changing over time. Stars are born, galaxies collide, black holes grow, but nothing in nature lasts forever. Even the universe itself may have a final fate. Modern cosmology suggests several possible endings for the cosmos. Some are slow and silent. Others are violent and dramatic. To understand what the end of the universe might look like, we must first understand how the universe works today, and how scientists discovered that the universe is expanding. The discovery of an expanding universe. For much of history, many scientists believed the universe was eternal and unchanging. Even when Albert Einstein developed the theory of general relativity in 1915, the prevailing assumption was that the universe must be static. However, Einstein's equations suggested something unexpected. The universe could not remain perfectly stable. Gravity should cause it either to expand or collapse. At the time, there was no observational evidence for cosmic expansion, so Einstein introduced a term called the cosmological constant to balance gravity and keep the universe static. But observations soon revealed that the universe was not static at all. In the 1920s, astronomer Edwin Hubble made a groundbreaking discovery. He found that distant galaxies were moving away from us. Even more surprising, the farther a galaxy was, the faster it appeared to recede. This relationship became known as Hubble's law. It revealed something profound. Space itself is expanding. The Big Bang in cosmic history. If the universe is expanding today, then in the past it must have been smaller. Much smaller. When scientists traced this expansion backward in time, they reached a point when the universe was extremely hot and dense. This early state is known as the Big Bang. Evidence for the Big Bang comes from several observations. One of the most important is the discovery of the cosmic microwave background. This radiation fills the entire universe and represents light released about 380,000 years after the Big Bang. Together with observations of galaxy expansion and the abundance of light elements, it provides strong support for the Big Bang model. Today, scientists estimate that the universe is about 13.8 billion years old. But what happens next? The role of dark energy. For many decades, scientists believed that gravity would gradually slow the expansion of the universe. After all, every galaxy attracts every other galaxy. Gravity acts like a cosmic brake. But in 1998, astronomers studying distant exploding stars discovered something astonishing. The expansion of the universe is not slowing down. It is speeding up. This discovery suggests that the universe is dominated by a mysterious form of energy known as dark energy. Dark energy appears to make up about 68% of the universe. Its nature remains one of the biggest mysteries in modern physics. But its existence has enormous implications for the ultimate fate of the cosmos. TH e Big Freeze. The most widely accepted scenario for the end of the universe is known as the Big Freeze. In this scenario, the expansion of the universe continues forever. Galaxies gradually drift farther and farther apart. Over billions and trillions of years, stars slowly burn through their nuclear fuel. Eventually, star formation stops. The universe becomes darker, colder, and emptier. Existing stars will eventually die. Some will collapse into white dwarfs. Others will become neutron stars or black holes. After trillions of years, the universe may contain only faint stellar remnants and black holes drifting through vast darkness. Over unimaginable timescales, even these remnants may disappear. Black holes themselves slowly evaporate through a process known as Hawking radiation, predicted by Stephen Hawking. This process is incredibly slow. A black hole, the mass of the sun, would take far longer than the current age of the universe to fully evaporate. But eventually, even black holes may vanish. The universe would then approach a state of maximum entropy. A cold, dark, nearly empty cosmos. The Big Crunch. Another possible fate of the universe is the Big Crunch. In this scenario, gravity eventually overcomes cosmic expansion. The expansion slows, stops, and then reverses. Galaxies begin moving closer together. The universe begins to contract. Temperatures rise. Matter becomes increasingly compressed. Eventually, the entire universe collapses into an extremely hot and dense state, possibly similar to the conditions of the Big Bang. Some cosmological models suggest this collapse might lead to another expansion phase, a cosmic cycle of expansion and contraction. However, current observations indicate that the expansion of the universe is accelerating. Because of this, the Big Crunch appears unlikely under current models. The Big Rip, one of the most dramatic theoretical possibilities, is the Big Rip. This scenario occurs if dark energy becomes stronger over time. Instead of merely accelerating expansion, dark energy would eventually overpower all forces in the universe. First, galaxies would be torn apart. Then, solar systems. Eventually, planets and stars themselves would disintegrate. Finally, even atoms could be ripped apart by the accelerating expansion of space. In the final moments, space-time itself might be torn apart. Fortunately, current observations do not indicate that dark energy is increasing in this way. But the possibility cannot yet be completely ruled out. Vacuum decay. Another theoretical possibility involves the structure of quantum fields. According to some interpretations of quantum field theory, the universe may exist in a metastable vacuum state. This means our current vacuum might not represent the lowest possible energy state. If a more stable vacuum state exists, the universe could potentially transition to it through a process called vacuum decay. In such a scenario, a bubble of lower energy vacuum would form somewhere in the universe. This bubble would expand at nearly the speed of light. Inside the bubble, the laws of physics could be completely different. Atoms might not be stable. Stars and galaxies might not exist. Everything in the universe could be instantly destroyed as the bubble expands. However, there is currently no evidence that such a transition is imminent. The cosmic timescale? One of the most remarkable aspects of these scenarios is the timescale involved. The universe does not end anytime soon. The age of the universe today is about 13.8 billion years. But the end of the stellar era alone may occur trillions of years in the future. The evaporation of the largest black holes could take more than years. These numbers are so large that they stretch the limits of human imagination. What would the end look like? From a human perspective, the end of the universe would not be a single dramatic event visible from Earth. Instead, it would be an unimaginably slow transformation. The night sky would gradually change. Distant galaxies would disappear beyond the observable horizon. Stars would grow rarer. Darkness would spread across the cosmos. If the Big Freeze scenario is correct, the universe will slowly fade into silence. A vast cosmic ocean of cold particles drifting through darkness. Conclusion: the universe is still evolving. The ultimate fate of the universe remains one of the greatest questions in science. Several possibilities exist: eternal expansion and cosmic cooling, gravitational collapse, catastrophic expansion, quantum vacuum transition at present. Observations suggest that the universe is likely heading toward a long, slow Big Freeze. But the true answer may depend on physics we do not yet fully understand. New discoveries about dark energy, quantum gravity, and the structure of space-time may one day reveal the universe's final destiny. For now, the cosmos continues to expand. Stars continue to shine, and the story of the universe is far from over.